Okay, so here we have the next question on the menu, which is, in big letters, the triple scalar product. What is the triple scalar product as a definition? What's the formula? And what is an example? So the triple scalar product, I'll think of, this was the example that I was taught when I first learned about the triple scalar product. It was in the context of moments. So if you needed to find, if we have a lever attached to a something that wants to rotate, and we're trying to find out the moment, which is kind of like the torque, we will need the triple scalar product to help evaluate that. So this is very useful for mechanics and physics. Off the top of the head, I'm not really certain of any other situations where this might be useful. Maybe in pure mathematics as an exercise, but basically what it means is, the definition is it is the projection of a cross product onto a unit vector. Or along a line, a specified direction. Projection of a cross product on a direction vector. Okay. So the formula for this is going to be, the triple scalar product is going to be, right here you see it as like A, the sheet of vectors, A cross product B, that's not multiply, that's cross product, dot product that with C. Yeah, so this would be a triple scalar product. Hair poking me in the eye. Okay. So assuming that these are vectors, we need to write them out like this. So we know that they will be made up of multiple components. So let's imagine that they are three-dimensional vectors. So we're going to have like AX, and that's in the I direction, plus AY, that's in the J direction, plus AZ, that's in the K direction. Oops, I should draw that as a axonal series complex to note that these I, J, and K, these are representing unit vectors along the X, Y, and Z axis. Okay, so here we're going to follow the same procedure for BY, for all of B's components, and the same for all of C's components. Okay, so how we can evaluate this is we could do it with a determinant. If you're not familiar with determinants, don't be worried. I'll show you exactly how this procedure will work. Okay, so suppose that we have A cross B dot product C. Essentially, we want to find the determinant, and you write that like this, and you're just going to write out all of your vectors inside here just like this. Okay, and we're kind of going to draw it like a matrix, and yeah, you can actually do this like a lot easier than this way. You don't need to do it in two separate steps. You can actually do it in one step if you just find the determinant. So you want to draw your vectors in here. So AX, AY, AZ, BX, BY, BZ, CX, CY, and CZ. Okay, so this is essentially what we want to be, what we want to use to calculate this. And to find the determinant, essentially, what we will be doing is we will find the determinant of this by doing this following procedure. So the result of this is our first term. By the way, the result of this is always going to be a scalar, okay? So keep in mind, triple scalar product, the result is going to be a scalar. So don't worry about the I, J's, and K's. We're just going to multiply along the diagonals and add them all up, and then the opposite direction diagonals and add them up as well. Oftentimes it's going to be a little bit helpful to draw out your lines out here as well. AX and AY, BX and BY, CX and CY. This can make things a lot easier. So essentially we want to have these multiplied like this. Okay, and in the other direction, maybe I'll do red for the other direction. We want to do it this way, but we're going to subtract these multiplication terms. Okay, now you see that instead of starting it at this AY right here and multiplying here, we're, you know, it's going to be easier to do it like this. That's why we wanted to redraw out these terms out here. Okay, so the red are going to be subtracted and the greens are going to be added together. So we will have AX times BY times CZ plus AY times BZ times CX plus AZ BX times CY. And now it's the red terms, so they're minus. So this shall be AZ, BY, and CX minus AX times BZ times CY minus AY times BX times CZ. Okay, and this will be your result of this calculation. The triple scalar product A cross B dot product C. Okay, so hopefully this is a clear example on how we could see this in action. Like if you were to just have numerical vectors here and sub those in, it would be, you just do this calculation. So it's all multiplications. Inside the brackets. Okay, so yeah, this shall be good like that. Cool. And here, like, you could just do the cross product individually and then you dot product it afterwards, but in my opinion it's going to be a lot faster to do it like this. So faster with determinant method. If you don't know what a determinant is, don't worry about that too much. You'll see that when you learn about linear algebra. It's a whole nother topic, but nothing to be concerned about. Okay, so we have a numerical example about this in action, and you know, as a result, in the end, you could hopefully see that you would come to a very similar conclusion. Okay, regardless of if you do it individually or as a determinants form. Okay, so here the above solution is good.